going to work through a practice test so that you can see how to work some of these problems. Keep in mind that you may see different questions on your practice test, but this will at least give you kind of a basis for some of the problems. So for number 1, there are 3 problems for this one. Perform the given row operations. So for the first one, they just want you to swap rows 3 and 1. So row 3 would become row 1. So 8, 5, 4, negative 2. We're not doing anything to row 2. And then row 1 would become row 3. So 4, 9, negative 7. The second one, they want us to multiply row 2 by 4 and then replace row 2 with that. So we're going to do 4 times row 2, 2, 6, negative 1, negative 6. And when we distribute that through, we will get 8, 24, negative 4, negative 24. So that's going to become our new row 2. So 8, 24, negative 4, negative 24. And then the rest of the rows stay the same. So 3, 9, 8, negative 8, and negative 4, 1, negative 7, 4. All right, the third one, they want us to do negative 3 times row 3, then add that to row 1 and replace row 1. So let's see, negative 3 times row 3. So negative 6, negative 3, negative 2, negative 8. So it'll be 18, 9, 6, 24. So that's our row 3 after we multiply through by negative 3. Then we want to add row 1. So that's 9, negative 1, 3, 7. And that's going to give us our new row 1. So that'll be 27, 8, 9, and 31. So that's our new row 1. So 27, 8, 9, 31. And the other rows do not change. All right. Number 2. Okay, for this one, they want us to do 3 times matrix D and add that to 2 times matrix B. So I guess let's do an intermediate step here. Let's figure out what 3D would be. Oops. So 3D would be negative 3, 18, 27, 24. Negative 15, 6, 21, 15. So again, I'm just multiplying each of the elements in this matrix by 3. 12, negative 30, 30, negative 18, and then 9, 3, negative 27, negative 12. Okay, that's 3D, plus they want us to add that to 2B. So 2 times B. That's going to be negative 10, 16, 6, 14, 12, negative 8, 18, negative 2, 10, 20, negative 20, negative 14, negative 18, 2, negative 4, 0. It's possible that I will make mistakes in this video, so if I do, please feel free to post in the peer questions and answers board and let everyone know that you think there might be a mistake on a certain problem so that other people can be aware. Or if I didn't make a mistake, maybe someone can help you see why. Okay, so now we want to add these together. So negative 3, remember we're adding elements in the same position. So negative 3 plus negative 10 would be negative 13. 18 and 16 is 34. 27 and 6, 33. 24 and 14, 38. Now we're going to move on to row 2. Negative 15 and 12 is negative 3. 6 and negative 8 is negative 2. 21 and 18, that's 39. 15 and negative 2 is 13. Okay, on to row 3. 12 and 10 is 22. Negative 30 and 20 is negative 10. 30 and negative 20 is positive 10. Negative 18 and negative 14 is negative 32. Fourth row, we'll have 9 and negative 18 is negative 9. 3 and 2 is 5. Negative 27 and negative 4 is negative 31. And negative 12 and 0 is negative 12. Okay, number 3, use the Gauss-Jordan elimination method to solve. Show your steps. So your first thing, and it tells you what you should do in each step. So first, change the system of equations to a matrix. So we're going to have negative 11, negative 7, negative 67, negative 3, negative 2, negative 19. Okay, so once you put in your coefficients, and remember that it's important to make sure your equations are lined up. So your x's should be first. That's going to make up your first column. Your y's will be second. That will make up your your second column. And your constants should line up to be your third column. Okay, so the next thing it asks us to do is get a 1 in row 1, column 1. So in this position, they want a 1. So whenever you're getting a 1, you're always using division or multiplication. So we will want to divide by negative 11. Remember that they don't really like to use division when you're using matrices, so you just say, okay, well, I'm going to multiply by negative 1 over 11. So we're going to multiply the first row by negative 1/11, and then we're going to replace row 1 with whatever we get when we do that. So we'll get 1, 7 over 11, and 67 over 11. Row 2, we're not changing right now. Okay. Okay, so we did that. Next it says get a 0 in row 2, column 1. So the next step, is to make this negative 3 a 0. Whenever you're getting a 0, that's when you want to multiply the row with a 1. So you're going to be multiplying row 1 by the opposite of what you want to be 0. So since we want the negative 3 to be 0, the opposite of that is 3. So we're going to do 3 times row 1, then we add it to the row that we want a 0 in, and we replace the row where we want a 0 in. So let's do our scratch work. We're going to have negative 3 times row 1, and this is not going to be fun because we have fractions. So we have negative 3, negative 21 over 11, and let's see, what is 67 times 3 is 201, so I'll have negative 201 over 11. Okay, so that is row 1 once we multiply by 3, and then we need to add that to row 2. Oh, whoops, did I multiply by the wrong thing? I multiplied by negative 3, even though in red I said I should multiply by a positive 3. So let's go back. I should not multiply by negative. I said in red I should be multiplying by positive, so I'm going to fix that. So all my signs should be positive. Okay, so now I'm going to add row 2. So a negative 3, negative 2, negative 19. So we get 0, 21 over 11, minus 2. That's a negative 1 over 11. And so I'm just using the calculator to do this work for me instead of doing it by hand. So 201 over 11 minus 19 is negative 8/11. Okay, so this is now row 2. So we're going to have row 1 is the same as it was. And row 2 is now 0, negative 1 over 11, and negative 8 over 11. Okay, now it says get a 1 in row 2, column 2. So row 2, column 2, that's here. So we want that to be a 1. So whenever we're trying to get a 1, we always are using multiplication. So to get a 1, we multiply by the reciprocal. So we would want to do negative 11 over 1, that's the reciprocal, times row 2, and replace row 2. So let's see what we get when we do that. Negative 11 times 11 over 1, or 11, it's the same thing. 0, negative 1/11, negative 8/11. So when we multiply, we'll get 0, 1, and 8, because the 11s just cancel out with the denominator. So we have 1 7/11, 67/11, and the new row 2 is 0, 1, 8. All right, getting closer. Now the next step, it says get a 0 in row 1, column 2. So that's right here. We want that to be 0. So whenever we're getting a 0, we're going to multiply by the row that has the 1. So we're going to be multiplying row 2 by the opposite of whatever is in row 1. So that would be negative 7/11. Then we add it to the row where we want the 0, and we replace that row. All right, let's see what we get. So negative 7/11 times row 2, so that's 0, 1, 8, whoops, just 8. So that's going to be 0, negative 7/11, negative 56/11. So that's row 2, and we're going to add that to row 1. So 1, 7/11, and 67/11. And when we add that straight down, we'll get 1, 0, and let's see, 56, negative 56 plus 67 is 11. So 11 over 11 is 1. So this is the new row 1. So 1, 0, 1, and then the row 2 does not change. Okay, so now if we didn't make any mistakes, the answer is x is 1 and y is 8. Okay, number 4. Suppose Lloyd, Jeremiah, and Tara go to a donut shop. Lloyd buys 2 almond lover, 2 Boston cream, and 4 chocolate frosted donuts and ends up spending $15.82. Jeremiah gets 8 of the almond lover, 8 Boston cream, and 6 chocolate frosted donuts for a total of $44.38. And then lastly, Tara spends $29.55 on 7 almond lover, 2 Boston cream, and 6 chocolate frosted donuts. How much does each type of donut cost? Okay, so there probably isn't even enough room right now for me to do this. But let's set it up, and then maybe we'll have to move the screen down some. Okay, so first it's important to be able to write an equation for each person. So we have almond lover, Boston cream, and chocolate frosted donuts. So it looks like it's pretty easy to set it up as A, B, and C. So let's do that. So 2 almond lover, so 2A, plus 2 Boston cream, so 2B, and 4 chocolate, so 4C, is equal to 1582. So that's Lloyd's equation. And then Jeremiah's equation would be 8A plus 8B plus 6C is equal to 44.38. And then Tara's equation would be 7A plus 2B plus 6c is equal to 2955. Okay, so you would set this up. You can either set it up as a matrix and use your row operations, or you could use elimination or substitution to do these. I don't know. There's not really one way that's easier than the other. It's just your preference. So I guess we can just go ahead and do, I'm trying to look at it and see. I don't know, it's probably just as easy to do elimination, but you can also do the matrix algebra. So here we have three equations. This is equation 1, this is equation 2, and this is equation 3. If you're not going to use matrix algebra and instead you're going to do the elimination method, you're going to have to do it 3 times. So I would use equations 1 and 2 first. Okay, so I'm going to write those down. So 2a plus 2b plus 4c is equal to 1582. And then 8a plus 8b plus 6c equals 4438. Okay, so what I'm going to do here is I'm going to try to eliminate the b variable. So if I want to eliminate the b variable, I would need to multiply the top equation by -4, because -4 times 2 is -8, and that will be the opposite of 8 in the bottom equation. So if I multiply through by -4, only on the first equation, my new equations will be -8a minus 8b minus 16c is equal to, and don't forget to multiply the last thing by -4 as well. So 1582 times 4, a -4 is -63, 28. The second equation I'm leaving as is. Okay, so now I want to add these together. And let's see what happens. Oh, well, actually, in this case, this kind of works out well. The a's and the b's cancel out because they're both opposites. So this will end up leaving me -10c is equal to, let's see, -6328 plus 4438 is equal to -1890. I can divide by -10, and that'll give me 189. Okay, so C is 189. So we've now discovered what a chocolate frosted donut costs. So that's the answer to C. Okay, so now we can kind of do this process again to try to figure out another variable. So I used 1 and 2, so now I need to pick 2 equations, not 1 and 2, but I can either pick 1 and 3 or 2 and 3. I'm going to pick 1 and 3. Okay, so I have 2a plus 2b plus 4c is equal to 1582, and I have 7a plus 2b plus 6c is equal to 2955. And so here I can see that the b's are almost canceling out, but they're the same sign. So if I want them to cancel, I could multiply through by a -1. It doesn't matter on which equation, just one of the equations. And then they would be opposite. So I'm going to multiply the bottom one. So the top one I'm leaving the same. And the bottom equation, I'm going to multiply everything by a negative. So -7a minus 2b minus 6c is equal to 2955. Oops, negative 2955. And then I'm going to add those together. So that's going to give me -5a minus 2c is equal to, let's see, 1582 minus 2955 is -1373. Now in this situation, you could have eliminated B or you could have worked to eliminate A. But you would not want to eliminate C because you already know the value for C. So you definitely want to keep C in your equation when you add these two together. Because now what you want to do is plug in 189 for C so that you can figure out A. So we'll have negative 5A minus 2 times 189 is equal to negative 1373. So 189 times negative 2 is negative 378. Okay, and then we need to add 378 to both sides. So it's going to give us negative 5A is equal to negative 1373 plus 378 is negative 995. And then we would divide by negative 5 to find A. So 995 divided by 5 is 199. Okay, so A is 199. So that means the almond lover is $1.99 each. Once you find two variables, let me erase this, then you simply plug those into one of your original equations to find the value of the third variable. So I would look and see which equation has the smallest numbers. That would be equation 1, so that's the one I would use. So equation 1 is 2 times A is 199, plus 2 times B, I don't know that, plus 4 times C is 189, is equal to 1582. So 2 times 199 is 398, and 4 times 189 is equal to 756. Okay, I've got like terms, so 399 plus 756, I can add those together. 1154. So 2B plus 1154 is equal to 1582. Subtract 1154 from both sides. So I get 2B is equal to, let's see, 1582 minus 1154, 428. And then divide both sides by 2. And you'll see that B is 214. So the cost of the Boston cream is $2.14 each. So again, this isn't the only way to work it out. It's just one way. This way is taking advantage of your knowledge of elimination. So if you're more comfortable with elimination than you are matrix algebra, you can use this way. But if you're more comfortable with using the matrices, feel free to do it that way, and you should still get the same answer. Okay, number 5. What are the dimensions of the following matrix? So remember, matrix dimensions are given rows by columns. So there are 2 rows, so 2, and there are 1, 2, 3 columns. So this matrix is the 2 by 3 matrix. Number 6, subtract. So the key here is making sure you distribute that negative to everything in the second matrix. So what I like to do is I like to make it an addition and go ahead and change all the signs in the matrix so that then I can just add. So now I can just do 6 plus 8 is 14, and I don't have to worry about the negative sign or any of that. Negative 2 plus negative 1 is negative 3. Negative 2 plus 5 is 3. 0 and 6 is 6. 8 minus 2 is 6. 8 minus 4 is 4. Negative 3 and 6 is 3. And 5 and negative 5 is 0. So again, if you have a subtraction, just change it to plus and change all the signs in the matrix following that. I think it's much easier. You're less likely to make a mistake with your signs. Okay, number 7. Given that A is this matrix, compute 3A. So we're just multiplying each element by 3. So -4 times 3 is -12. 2 times 3 is 6. 3 times 3 is 9. And 2 times 3 is 6. And that's all there is to that one. Number 8, a system of equations was written as an augmented matrix, which was row reduced to this. What's the solution? So some of these are going to be very straightforward, so don't overthink them. Remember that each column represents a variable, and then this last column is your answer. So for the one on the top row, this means x equals -1. If there's a 1 in the second column, that means y equals 2. And the one in the third column means z equals 1. So those are your answers. X is -1, y is 2, and z is 1. Use the Gauss-Jordan elimination method to row reduce. Okay, so we've got this matrix. This time it's not telling us all the steps, but we're going to get through it. So, and let me just say also, let's say you hate using Gauss-Jordan. On the one above, it told us we had to do, let's go back and look at it, because I want to make a point here. This one, we had to do every single step and show each step. So we have to use this method, because if we don't, we won't get all of the answers that we need. For number 9, we could do this one exactly like, I think it was number 3. We would do the same steps. So we'd get a 1 where the -5 is, then we would get a 0 where the 12 is, then we would get a 1 where the 7 is, then we would get a 0 where the -3 is, and that would be the answer that we put in as our row reduced matrix. However, if you're better with elimination, you can actually do that and kind of sneak your way to the answer, because here's the deal. A row reduced matrix always has 1s on the diagonal and 0s everywhere else. And then this blank is going to be your X answer, right? And this blank is going to be your Y answer. So if you use elimination and just find your answers, you can simply write the 1, 0 X answer, 0, 1 Y answer, and get your answer that way. Okay. So I'm just telling you this in case, like me, maybe this isn't your strength. Using the matrix algebra is not my strength. So I would find an alternative way to do it whenever possible. So let me just show you how to do that. Again, if you want to know how to do it using matrix algebra, go back and look at our example from above. It's going to be the same way. Just to show you something different, this is going to be 5x. Let me write it up here. This first row makes an equation, 5x minus 3y equals -7. And the second row makes an equation, 12x plus 7y equals 16. Okay, so now what I want to do is solve this. And I'm going to use elimination method. Since the y coefficients are smaller, I'm going to use those. And I'm simply going to multiply them by each other. So since the coefficient of the top one and y is -3, I'm going to multiply the bottom equation by -3 and the top equation by 7. So I'm just multiplying these by each other. So that's going to be -35x minus 21y is equal to -49. And on the bottom, it's going to be -36x minus, what happened here? Oh, I don't want to multiply by a negative. Sorry. I wouldn't multiply by a negative because they are already opposites in sign. So multiply by a 3. So it'll be 36x plus 21y is equal to, let's see what 16 times 3 is, 48. And then I would add these together. So remember, I just multiplied the y coefficients by each other, but don't do it by a negative because you want one to be positive and one to be negative so that they will cancel out because they're opposite signs. So this is going to give me 1x is equal to negative 1. So the answer for x is negative 1. So that means I can write that right here. So this is going to be 1, 0, negative 1. This is going to be 0, 1, and whatever I get as the answer for y. So now I'm simply going to plug this in to one of my original equations. It doesn't matter which one, and figure out what y is. So negative 5 times x, which is negative 1, minus 3 times y is equal to negative 7. So this is going to be 5 minus 3y equals negative 7. Subtract 5 from both sides. So this is going to be negative 3y is equal to negative 12. Divide by negative 3. So y is 4. So that's going to go in for the answer for y. So there's your reduced matrix. I prefer this. It's shorter. To me, it's simpler. So this is one way kind of around the matrix algebra. So just trying to present you with options here. All right, number 10. Write the augmented matrix of the system and then use it to solve the system. If the system has an infinite number of solutions, express them in terms of the parameter z. Okay, so again, we have options. If you have to write the augmented matrix, that's easy to do. We could do that if we needed to. We would just write negative 15, negative 5, 2, negative 56, negative 3, negative 4, 1, negative 19, 3, 1, negative 1, 10. Now we can move forward and use this matrix in order to solve the system, or we can use elimination method. So I'm going to propose using the elimination method rather than the matrix algebra. Okay, so we have 3 equations. We have equation 1, 2, and 3. So we need to pick 2 equations to use in order to eliminate the variables. I'm looking at z's because all of those are really small numbers, and you can see that right here, these are already opposites. So if I combine 2 and 3 together, those are going to cancel right out, and it's going to help me a lot. So that's where I'm going to start. Remember that whatever you choose to cancel the first time, though, you have to do that the second time, unless more than one variable cancels out. So I'm going to combine equations 2 and 3 because the z's are going to cancel out. And actually, now that I'm looking at it, the x's are going to cancel out as well. All right, so if I add these equations together, the x's are opposites as well as the z's. So I'm going to have negative 4y plus y is negative 3y is equal to negative 9. Divide by negative 3. So y is 3. Okay, so I've already gotten one answer. I can put a 3 next to the y. That one's done. Now, instead of using 2 and 3, I need to use a different combination. So I'm going to use, it doesn't really matter, let's use 1 and 3. The only reason I'm picking 1 and 3 is because they have opposite signs. So I'm going to use those two. So equations 1 and 3. So negative 15x minus 5y plus 2z is equal to negative 56. And then 3x plus y minus z is equal to 10. So again, I don't want to cancel out the y's because I know the y. So I either need to cancel out the x's or the z's. I'm going to stick with the z's. So if I multiply through by a 2, I'm going to get the opposite of the top equation. So the top equation stays the same. The bottom equation becomes 6x plus 2y minus 2z is equal to 20. When I add these together, the z's cancel out. So I'm going to have negative 9x minus 3y is equal to negative 36. Now I know the y value, so I can plug that in. So negative 9x minus 3 times y, which I found was 3, is equal to negative 36. And this will allow me to solve for x. So combine those together, add the 9 to both sides. So we get negative 9x equals negative 27. Divide by negative 9. And you see x is also 3. So x is also 3. Okay, last step, we got to find the z. If we know x and y, we can plug those into one of the equations to find z. So I'm just going to pick the last equation. So 3x, 3 times 3, plus y, which is 3, minus z is equal to 10. So this will be 9 plus 3 minus z equals 10. So that's 12 minus z equals 10. Subtract 12 from both sides. I get negative z equals negative 2. Divide by negative 1. So I get z is 2. So 2 is the answer to z. That takes us through one full practice test. I'm hoping that this is helpful to you as you're studying. Again, remember that there are options, and it's okay to solve things in different ways, because we've learned this before in class. We learned what the elimination method is. So now you have options. You can use the matrix algebra, or you can use the elimination method to solve these.